We began by saying that a production function tells us for any combination of labor and capital how much output we're going to be able to produce. But in the short run, we hold capital fixed, and so we operate on a slice of that production function. That slice can be graphed in 2 dimensions, and it's simply that production function as a function of labor with capital held fixed. We then thought about the firm's profit maximization problem in the short run, where short-run profit is equal to your revenues, the price times the output that you sell, minus your labor costs, where the capital costs aren't true economic costs in the short run. The firm chooses how much to produce with how much labor to maximize this profit, subject to the constraint that what it produces must be producible with that short-run production function. So the short-run production function is the constraint, and then the firm moves to its highest possible profit line, where the profit line is given by the profit equation. That line will reach a point of tangency at the profit maximizing production plan. It has a slope of W over P, and the short-run production function has a slope of marginal product of labor. By setting those equal to each other and then multiplying through by the price, we got the short-run profit maximizing condition that price times marginal product of labor, or what we've called the marginal revenue product of labor, must be equal to the wage when the firm profit maximizes in the short run. We now are going to do the same thing in the long run and provide some intuition for what the profit maximizing conditions are when both labor and capital can be varied by the firm. Now the firm is going to maximize profit where both the labor costs and the capital costs are true economic costs, because both of them can be changed. Neither is fixed. So profit's going to be equal to revenue minus the labor costs minus the cost of capital, where the price of capital is denoted by R, we call it the rental rate of capital, and capital by little k. So now profit is revenue minus labor costs minus capital costs. The firm will maximize that, and now it'll choose how much to produce and what combination of labor and capital to use to produce it. But it'll have to do that subject to the constraint that X must be producible with the combination of labor and capital that the firm chooses. This equation for short-run profit gave us the equation of a line, a profit line, and the higher the profit, the higher that line would sit in our picture. When we add this term, the equation becomes the equation of a plane. And so you can imagine a plane, a sheet of paper, sitting in this space. And there'll be lots of these sheets of paper, one for each profit level, just like there were lots of profit lines over here in this picture, one for each profit level. And the firm's going to try to get that to the highest possible profit sheet, something where the sheet will then ultimately lie somewhere here and form some tangency with this production function. The slice of that tangency that holds capital fixed is still going to look exactly like that. So this short-run equation is still going to hold. But now there's another slice we could take, the slice where we hold labor fixed. And have a tangency at that point. When we take that slice, we get a very similar picture. We get a picture where labor is held fixed, and we vary capital. So we're just varying capital, holding labor fixed, and see how much output we can get. That slice also has that same shape, only now the slope of that slice is the derivative, the partial derivative of f with respect to k, because we're varying k, which is just equal to the marginal product of capital. It tells us how much output is going to go up as we vary capital. So that's just the definition of marginal product of an input. How much additional output do we get from one more unit of the input? If we differentiate with respect to capital, that becomes the marginal product of capital. Just as up here, the marginal product of labor was the partial derivative of the production function with respect to labor. So we have a similar slope, only now it's the marginal product of capital. And then if we take that slice with the sheet of paper that's tangent to it, that profit plane, we get another line. And that line is going to look exactly like this. It has to be tangent because the sheet of paper, the profit plane, is tangent to the whole production function. That line is going to have a similar equation, except the slope now is going to be R over P instead of W over P. But it's exactly the analogous thing to this picture here. Which means that at this tangency, where that plane is tangent to the whole three-dimensional surface, it has to be that the marginal product of capital is equal to the rental rate divided by price. If we multiply through, so the marginal product of capital is equal to the rental rate over price, if we multiply through by price, we get that the price times the marginal product of capital is equal to the rental rate. An equation very similar to the one we found before in the short run. Only now this is the marginal revenue product of capital, the additional revenue we get from hiring one more unit of capital. And we're going to keep hiring capital until the marginal revenue product of capital is equal to the price of capital, just as we kept hiring labor until the marginal revenue product of labor is equal to the wage. So we can see the intuition by just sort of imagining that sheet of paper, that profit plane tangent to this surface, and taking slices along the lines where we hold labor and capital fixed, that these pictures give us these two conditions that have to hold at this profit maximizing production plan in the long run. So profit maximization in the long run, when you can vary both capital and labor, is going to imply that the short run condition for profit maximizing holds, price times marginal product of labor is equal to the wage, and this new condition holds, price times marginal product of capital is equal to the rental rate.